everyone. Welcome back to episode 9 of Things We Read This Week. I'm Jordan Nanos, back with Hunter Almgren. We got a big show talking about a few technical topics that we're going to jump into right away, and how the guys are headed to SC24 next week. First time in a while getting together in person.
Yeah,
Um, Hunter,
yeah,
what you
it's
been
gonna
up
be
to these
fun.
past 2 weeks?
Well, this week, I got deep into the world of targeted advertising, which was fun. Um, what's interesting about it is it's kind of like high frequency trading in the sense that you're pulling data and then taking action on it, as close to real time as possible. But everyone always says like, oh, ads follow me around everywhere. Turns out they do.
In real time, low latency, high
Yep,
frequency.
absolutely, absolutely.
Okay, so let's jump right in. There was a I feel like we've drifted into politics a little bit on the show, talking about all the big data center moves and stuff like that. And maybe we'll do that again today. But I want to start with something pretty technical. Um, and just because I think it seems that all of the AI trends are kind of downstream of stuff like this. So um, Tim Detmer's had a little tweet storm this week about um, the future of quantization, let's say, for large language models. For those who don't know, basically taking the weights of a model and squeezing them so that they can fit on less memory space on a GPU or even a CPU. Tim was a uh, researcher at University of Washington. I think he's now moved on to like a academic position somewhere else, but he created the popular library called Bits and Bytes.
It,
Um,
it actually says he's Carnegie Mellon right on the right.
Here we go, Allen AI and Carnegie Mellon. Perfect. When he was at the University of Washington, he created Bits and Bytes, which I used at the beginning. Was kind of the first approach to squeezing those models down, quantizing them. And his tweet starts with, "This is the most important paper in a long time." And what it means is there's basically strong evidence that we've reached the limits of quantization. Um, and so if you kind of take a step back, what this means is that, like, okay, when NVIDIA introduced the V100 GPU, the Volta series GPU, and then the A100, was really the first time that people started using low precision for machine learning, which is kind of the opposite of HPC, where high precision is the game, right? You want to have
Sure.
FP32 or double precision FP64 to
FP64. Yeah.
keep all the, you don't want to round off, right? But machine learning models operate in the space of, like it's about accuracy. It's about like aggregate performance, and their low precision is kind of the game. So it started with FP16, and then with the H100, recently everybody's moved to, well, not everybody, but a lot of operations in both training and inference have moved to float 8 natively in the hardware. But people have also been kind of squeezing things down and making int 4 work, making float 4 work, making even lower, combinations of different, um, like different strategies where you can have weights and activations and biases treated differently in the model, um, and then stored differently on disk. But the point of this paper is that this is kind of run out. We've run out of bits to round off, and the trend for models is to train them on more data. And the more data that you train on, or the larger the model gets, the bigger some of these weights get. There's single neurons that can be responsible for all sorts of different things, and the weight is
Hmm.
like really big, and the accuracy is really important for that one neuron. And so basically, you lose a ton of performance if you try and quantize the largest models, um, trained on the most data. And Tim sums it up and says, arguably, most progress in AI has come from improvements in computational capabilities. This goes back to something I talked about in a previous episode called The Bitter Lesson by Rich Sutton, where it kind of says in AI, you can do all these different techniques, but at the end of the day, progress marches forward relentlessly, almost at the pace that computational intensity improves. The amount of compute you can fit in improves. So the researchers are saying that we're hitting a plateau. um, what are your thoughts on, I don't know, AI plateauing a little bit and sort of the downstream effects of this research?
You know, I kind of equate it to the cycle that we in the tech space have been on for quite some time, where it's hardware outpaces software, software outpaces hardware, and we are constantly swinging on that pendulum, right? You saw this in the virtualization space with VMware, where, you know, we had hardware that was so powerful and only being 20% utilized for our applications. And then ESXi came out and, oh, now I can get 10 applications or 10 servers on a single physical host. And now I'm utilizing 70, 80, 100% of that hardware. Because at that point in time, hardware outpaced software. And then we swung back where now I've got VMs that are so large and so performant that I can't fit as many of them on a single physical hardware. So now I have to build these massive VMware clusters and cluster sizes, and then start to worry about business continuity, availability, et cetera, right? I mean, I feel like there was always going to be a point where the plateau would happen, right? I
Hmm.
feel like it's inevitable. Um, as to plus, like with quantization in general, to your point, right? I mean, you can only go so far before you round off so much that you're just getting no results out of the model, right? Like there's inaccuracies, there's no way to get around it, right? And so yeah, you can only go so far for sure. And I think that, we've kind of seen that at least a little bit with you and I playing around with Llama 3 405B, right? It's like, yeah, it works great at full precision, but then when you start bringing it down, weird things start to happen. So if we're going to keep seeing the trend of 500, 600, 700 billion parameter models, like you're going to have to buy a whole NVL 72 rack to just one run instance. I
Yeah,
mean,
get
we're
one
kind of,
forward pass back from the model. Yeah, it's
yeah.
and it seems like, well, there's a difference in feeling in my mind between the user experience where the more functionality that's added to these models,
Mhm.
there's incredible leaps in the user experience. Like we talked about computer use from Claude last week, the vision stuff. I sent that this morning to you guys. It's like we used to have whole, software stacks based on custom models for OCR where you got like a special model for a receipt and a different model that's trained for the,
Yep.
the form that you're filling out. And now it's just like 3.2 vision 90B llama, like
It does it
throw
all.
it at
Like
it,
we
right?
just, yeah.
But so the functionality is there where you add like the different modalities, but the improvements in reasoning for like a classic text in, text out, what we saw from GPT-3 when it was released in the first ChatGPT seems to be plateauing. Like you can just see it in the benchmarks. They have to invent harder benchmarks because they're at like 90% on the multilingual understanding benchmark and stuff like that.
Hmm.
So I hope that we can continue to scale different modalities, but I'm also concerned that like you will not just meet and exceed human reasoning in language if all you're training on is human reasoning in language on the internet.
So do you think we're going to get to a point where instead of continuing to scale up, we start scaling out? And what I'm kind of meaning by that is we start breaking up the functions of these models again, where we go back to, well, here's your OCR model, and here's your vision model, and here's your, XYZ model, right? Like, do you think we're going to get to a point where, like, okay, this is no longer sustainable to continue scaling up, so now we need to start scaling out?
Yeah, and we've seen it. So, I mean, for example, there was another model that was released called Quen from a Chinese AI lab that's only 32 billion parameters and outperforms GPT-4o and Claude 3.5 Sonnet on the top coding benchmarks almost across the board.
Hmm.
Um, so, and those models are rumored. The big rumor with GPT-4 was that it was a 1.8 trillion parameter mixture of experts model. which the name kind of implies the specialization of certain, you know, experts within the model. It's not exactly how it works, but the point is that um, I think certainly we're going to see specialized models that are better at vision, better at code, better at math, better at like different reasoning capabilities, long context, stuff like that.
Hmm.
Um, but that seems to be a tick-tock based on the existing hardware or the existing amount of data. So like you saturate what you can train with a massive cluster of H100s. You have all the H100 class models get released with a certain amount of data. And then after the big hero run happens, you start to create specialized smaller models from that. And then you kind of wait for Blackwell. Blackwell comes out. I think we're going to see a whole nother round of new foundation models that are absolutely massive and can only run inference on a, like you're saying, 8, 16 way Blackwell because they're like 2 trillion parameters.
Yeah.
And then we're going to start to see the smaller, vision and coding and whatever specialized models fall out from that. Um, it's just becoming more and more of a rich man's game where like
Yeah.
you 2, 3 years ago, you could genuinely train a frontier class language model with a cluster of 512 A100s or something, right? And now we're talking about the rumors are, well, okay, the videos are for 100,000 H100 clusters, and the rumors are that Blackwell is going to be multi-data center training because you got to split it across different power grids.
Oh man, swarm learning 2.0. Let's go.
Yeah, yeah. Yeah, I think they trust the other entities. But I mean, we covered this. Microsoft is paying people to lay fiber, um, building data centers left and right. I think you got an
I
article
just,
coming up, right?
yeah, and I just saw Sam Altman's SMR startup Oklo just got a bunch of orders. Like it's like
Yeah.
actual orders, not just vaporware pie in the sky stuff, you know? So it's like it's interesting. And to your point, right? I think it is becoming a lot more of a rich man's game in the sense of just the infrastructure required to
Well, I
build
think
these.
yeah, I think it's been clear that the infrastructure required to build is a rich man's game for H100. What I think is unique about this is that we're now seeing two trends on the inference side that also
Yeah.
make inference a rich man's game. You
Hmm.
cannot, like most people cannot download the 405 billion parameter version of Llama 3.1 because it requires an 8-way H200 or MI300 system just to get one forward pass in full precision. So then they quantize and they stuff it down. And then, like you're saying, I saw on the ARM-based systems, it's just lower performance, right?
Hmm.
Um, but the other thing that's happened is that now with chain of thought prompting, you're also um, basically incurring a bunch of latency before getting a response. So it's like only certain problems, really complicated problems, are actually going to be passed to the model. And now it's like one question, 20 seconds before you get a response. And maybe it solves a really complicated math problem, but what are you actually going to use for day to day kind of daily driver coding tasks? That's not that's not a 2 trillion parameter model. At least um, that's not financially feasible today, I think.
Yeah.
So, um, you know, uh, here to Quen and 32B and Nemotron 70B, and let's keep going for the private self-hosted stuff and and hope that people keep open sourcing some of these trillion parameter models in the future.
Yeah. And I think also too, speaking of open source trillion parameter models, what is interesting to me that's kind of happening, just switching gears a little bit, that's happening in or what I'm starting to see happen in that space is, the rise of custom chips, right? Moving away from NVIDIA, building things that are purpose built and more specific to training and, potentially lower power footprint as well, right? You've always had the, you know, companies like Grok, GROQ, the accelerator, and other alternative, got to clarify that now.
Yeah, yeah.
The alternative accelerators out there, Qualcomm has their AI 100, Intel's got Gaudi 3, but you've got these purpose-built accelerators. And I read an article earlier about how Amazon is looking to increase its investment in Anthropic, but there's a catch. They want Anthropic to start using Trainium as opposed to general purpose NVIDIA chips. What I find interesting about this is, should this happen, what's to stop Microsoft from saying OpenAI now has to train on Maya? Or what I mean, like, because obviously Microsoft announced, I think it was earlier this year, the Maya 100, right, their AI chip for running AI workloads in Azure. What's to stop them from saying, hey, you want to keep this money train rolling, like, you need to start moving over to Maya as opposed to just continuing to down the path of NVIDIA. The second piece of that is, how does that potentially open the door for everyone else to start looking at alternative accelerators and maybe getting off of the the CUDA bandwagon, if you will, and maybe considering other things for certain workloads, coupled with the fact that if we're going to start seeing more specialized models, I don't maybe need an H200. Maybe I get a Qualcomm AI 100 because I'm just doing inference with no fine tuning, and that's really all I needed to do. And it's a small model, and you know,
Yeah. I mean, so just the point of having alternatives, like we are here. Um, I've been talking about this day for, I feel like 5 years, where one
mhm,
day in the future, it will not be Intel CPUs and NVIDIA GPUs. It will be one of 3 CPU vendors and one of 9 accelerator vendors that can all fit in an industry standard server.
yeah,
We are here, right? We have Intel, AMD, and NVIDIA GPUs, CPUs that all support CPU or GPUs from all 3 vendors, as well as specialized ones that you named, right? Qualcomm, Grok, Cerebras. There's all sorts of them.
mhm,
Um, and then you've got cloud service providers. I mean, Google trains all of the Gemini models on TPUs. That's custom silicon, right?
yep,
Um, Meta has their own chip for their recommendation system, right? Uh, the thing that I don't think I fully considered when I was coming in here and thinking about this is how kind of messed up the supply chain was going to be and how big these clusters were going to be. So there's a GPU that's available today that outperforms NVIDIA that anybody can buy. It's called the AMD MI300X. It doesn't outperform it on everything, but it outperforms it on some things, specifically large language model inference with VLLM. And people buy a lot of GPUs to run LLM inference. The problem is that AMD has had no incentive to manufacture that GPU so you can buy one in a PCIe system.
yeah,
They sell so many 8-way interconnected boards just to Facebook, just to Meta, that they have a whole business just doing this right now, right? And so we're at this point where the industry has these specialized chips, but we've also grown to the point where you can't actually buy them if you're not building a full data center of them, right?
right,
So I don't know how um, this is going to get democratized. It seems like the way is just through LLM flops, through tokens.
mhm,
Like the first abstraction layer is whether you call the OpenAI API, the Claude API, or the Gemini API. You could be getting tokens from an NVIDIA GPU on the first one, a Trainium accelerator on the second one, and a TPU on the third one, and your application works roughly the exact same way. The step to self-hosting that model on a GPU of your choice, where the model's Llama instead of ChatGPT, Claude, or Gemini, I think is a pretty big step for people. And when that step is Llama 3.1405B and it only runs on an MI300X or a H200 8-way, that's a $300,000 plus price tag to get your first server with 10 kilowatts of power. And that's not really what I had in mind when I was talking about this 5 years ago, and people were getting
Yeah.
their like first 8-way V100 300 watt per GPU, 3-4 kilowatt system in. Like,
Yeah, and I mean, thanks to, I think we've talked about this on a previous episode. I mean, thanks to IDC, most customers that own their own floor tiles are at an 8 or a 16 kW per rack design. So cool. At 16 kW, I can fit one server. Sweet.
yeah, yeah, one server per rack is not what I
Yeah.
envisioned in 2018 when I was thinking about this stuff. Yeah, yeah,
Me neither, right? And I would personally, I would love to see AMD expand their portfolio the same way that NVIDIA has done, in the sense of like, you look at NVIDIA's current portfolio, right? They've got the L4, the L40S, H100, H200, and you can get those, L4, L40S, H100 PCIe, right? And then you've got obviously the SXM boards, right, which are the 8-ways. But I'm working on this computer vision use case for a manufacturing plant right now. We're running that model on two L4s in a standard server, right? Like, that's all we need. So I think that if in this company's got a bunch of manufacturing sites all over the world. So I think if AMD really wants to get in on this space, maybe they need to focus more down market, right? Maybe they need to start and also, take a look at their software stack. But that's neither here nor there. I just think that from a pure hardware perspective, no one is going to buy an 8-way MI300X system for edge inference.
yeah. No,
It's not going to happen.
no, and everybody doing anything that's not centralized inference of a large language model has like been crowded out. Um,
Yeah. Well, and what's
you know,
interesting too is like Intel's out there telling people, I just saw a presentation a few weeks ago. You don't even need an L4. Just run inference on the CPU. Stick a low end, a Xeon,
well,
4000 series in a server, and just run your inference on CPUs at the edge.
it's not just Intel. So like it is with the M2, M3 chips from Apple,
Mm-hmm.
the M4 on the MacBooks. Now that they got the M4 Mac Mini, you can buy this like
I know, it's
$800.
like this big.
Yeah,
Looks like
yeah,
an Apple TV.
right. 20 tokens per second, 70 billion parameter model on that thing. Like you're like $800. That's like, I don't know, 5% of a H100. It's a 95% off deal. Like,
Yeah, for sure.
plug it in on your desk, doesn't consume a lot of power, 20 tokens per second of a NVIDIA Nemotron 70 billion parameters or something. It's incredible. Now people are taking the lightning ports and they're putting four of them together. So yeah, I think look, the democratization of AI in an interesting way, because I think AMD is, like you're saying, is neglecting the PCIe server market, is almost going to skip. It's going to go from massive cloud service with massive data center rack scale design, skip the average server that anybody can buy, and go right to workstation under the desk, or phone or tablet or little Mac on the corner. And there's going to be this big gaping hole in the middle where you're like, there probably could have been a lot of business done for a single server that can run a 70 billion parameter model at 20 tokens per second and support, you know, let's say 1,000 users, all, hitting maybe like 20, 30, 40 concurrent requests per second, and
Mm-hmm.
be like, yeah, that's a good solution for the enterprise. Get you an entry point of like 20, 30, 40 grand as opposed to 200, 300, 400,000. Like it's like two orders of magnitude cheaper to get in
Yeah.
with a Mac Mini right now. It's like there's something in that one order of magnitude cheaper than the 8-way server that should support 100 users with a coding assistant out of the box, right?
And you know, you and I were working on that. Speaking of coding assistant, where you and I were working on that project where it's like, hey, we need to support, you know, 1,000 developers or 1,400 users. Half are developers and half are, you know, other people who write unit tests and documentation and stuff like that. You know, I don't need 10 8-way SXM systems to make that work. I just
Yeah.
don't. So there's this whole middle of the market that are, you know, these companies are focused on a couple use cases, not 1,000. And they're like, hey, I got 1,000, 2,000 people to support. I can do this on 2 servers, 4 servers, whatever it ends up being, right? Even at production scale. Um,
Yeah.
and
It's a
that's, I
really
think,
interesting
the
sizing consideration with that because it's so arbitrary. Like
mhm,
when you size VDI or the amount of laptops you're going to buy, it's pretty straightforward. It's like how
simple
many
math.
people are going to
Yeah.
log in. And then there's some power users that are going to share a GPU for their AutoCAD thing. And like, okay, you got to make some estimates. But with this thing, it's like there's, um, you can't really back into it from the number of users as easily because sometimes 1,000 users log off for the weekend and there's nothing. And then sometimes 500 of the 1,000 users all upload a PDF at the same time and ask a question that's 100,000 tokens long, and the endpoint falls over.
We used to call those boot storms in the VDI space. It's like everyone comes in at 8 a.m. on Monday, logs into their thin client, and the cluster just falls over.
Yeah, Bootstorm. So there's this equivalent of a Bootstorm for a coding assistant, which is like, for some reason everybody has halftime at the Super Bowl and like heads over to the ask a question of ChatGPT or something. And I mean, software is able to handle this with load balancing and just like continuous batching. It works. People just, it doesn't fall over. People just wait a little bit longer for the
Hmm.
response.
Yeah.
But I think it's the experience of like driving a certain amount of throughput out of a model endpoint when like two H100s with a 70 billion parameter model can drive 1,000 tokens per second pretty easily. Divide that by 20 people at 50 tokens per second or 50 people at 20. Like, how many times are you going to have 50 concurrent requests coming into this endpoint? It's and backing into like 50 concurrent requests becomes 1,000 users, 10,000 users, 5,000 users. It's really hard for me to um, do the sizing properly without letting people just test it out and see how their users behave.
Yeah. I mean, I don't think that I've yet seen like something as simple as like VDI sizing, right? Like, you know, if I say I'm going to support 500 users and I'm going to have 2 vCPUs and 4 gigs of RAM per user, that's pretty simple math, right? Like, okay, I need this many servers with this many cores and this much RAM. Pretty easy. To your point, I have yet to see that for sizing these types of workloads where it's like, do you know, am I going to have 50 concurrent, am I going to have 50 people upload a PDF and ask a question at the same time?
Yeah.
Is, you know, how long is my response time going to be in that scenario, right? How long are my users waiting to get the desired output? I don't know. It seems a little ambiguous, and I think also that's what's driving at least all the companies that I talk to basically just start small, right? Like get a server or two, like get some kit on the floor and, you know, enable some people to start using it. And then, you know what, we'll see, right? It could be I need 2 more servers. It could be I'm good with the 2 that I have. It could be I need 10 more, right? I mean, there's really no other way to figure it out, at least not that I've seen. I mean, you can
Yeah.
make
Well, the
estimates for sure, like educated guesses, but
the other way that I've seen is just oversizing like crazy,
yeah,
motivated by the vendors selling the GPUs. But
sure.
um, the the result of that, I think, is even because of the software improvements we were talking about at the beginning of this pod. Like, let's say you size it for 1,000 tokens per second on that endpoint I was referring to, and you're like, I can support 50 concurrent requests from 20 users or something. And I've got a community of 1,000, and we'll only ever have 20 concurrent requests because not everybody uses it all the time. And if it works, let's say it works on 2 GPUs, you can support 1,000 users. The thing that happens is that you start with a 70 billion parameter model, and then the Quen model drops and it's 32, and suddenly your throughput's like doubled.
Mm-hmm.
And then you decide, I want to play with quantization. Seems like Quen can be quantized, and it performs well. So now you're double the performance from there. This is kind of the experience that we were describing at the beginning when talking about Tim Detmer's tweets about that paper, where I think a lot of people got used to that, like snap your fingers, download a new file, and suddenly I have double the performance.
Mm-hmm.
And that means that everybody's GPU purchases for inference have basically been oversized up until this point for those who are building big clusters and not starting small. I don't think that trend's going to continue.
I don't either.
Yeah.
I mean, similar to how you've heard just about every, you know, tech arms dealer on the planet talk about right sizing, right? Like, hey, pay us and we'll come right size your, cloud deployment or whatever it is, right? I mean, that's what's going to happen. It was always inevitable, right? When 10 years ago, when people started jumping into the public cloud, they over rotated, right? And then they have to go back and do a right sizing effort, right? It's going to be no different here.
Yeah. Makes sense.
All right. So switching gears a little bit to the facilities side of thing, couple fun articles that I read. One of them was Microsoft building data centers out of wood. Um, Interesting concept, kind of, bucks the trend of, conventional steel and concrete construction that most data centers are built on today. The interesting thing about it is the reason why Microsoft is trying this out is because they are struggling hard to meet the environmental commitments that they've given the street, right? So they're like, you know what? We're going to start building data centers out of wood, which is like, it's one of those things that if you look at like the way that houses have been built in certain regions over the years, like, think about like just how building materials have evolved, right? I'm in Chicago. You can drive all over the city and see mostly everything's built out of brick. Why is it built out of brick? Well, because there was a little thing that happened called the Great Chicago Fire that when they ended up rebuilding the city, they're like, no, we're not going to do that again. Wood, we're done with that. We're going to build everything out of brick, right? And then you've got, other places in other parts of the country that, they're either, pushing towards, what I would call like alternative, like newer building materials and stuff that is not only more sustainable, but more resistant to climate change.
Mm-hmm.
I'm I'm all for Microsoft trying out building a wood data center. Maybe just don't build it in Northern California.
Yeah. This one's Northern Virginia, it says, right? But
No, it is. Yeah, no, I know. I'm just saying, like,
the
this is going to affect where, if people start moving towards alternate building materials for data centers, this is going to affect where they can live.
Yeah, for sure. Yeah, my mind jumped when I read carbon negative in here. My mind jumped to this thing being in a treehouse that's still like, sucking out oxygen and spitting out, or sucking in carbon dioxide and spitting out oxygen, regenerative a little bit. Yeah.
Microsoft Azure Treehouse.
Exactly, dude. Yeah.
Deploy
They
your
have a pulley.
sustainable,
They're pulling the thing up. Yeah.
Deploy your sustainable AI workloads in our state-of-the-art treehouse.
Yeah, exactly. Yeah. Um, but obviously, this is just like um, replace the beams with like timber.
Yeah,
It seems cool. Yeah.
it is. It does seem cool. And then,
I
go ahead.
one thing that I guess excites me about this is that it seems that the AI industry moving things forward, even though it's generally unsustainable and like all of the carbon emissions for Llama 3 were a waste as soon as Llama 3.1 came out.
Hmm.
Um, it's cool that it has an impact of like dragging along other industries behind it and forcing them to innovate. When I was in school, a lot of my friends decided to go into other engineering disciplines. I did electrical engineering. They went to civil, they went into geological, mining, mechanical, and
Hmm.
some of them ended up working in these like auxiliary data center sort of um, companies. Like they're a mechanical engineer who works on heating, ventilation, cooling equipment and stuff. And they work on all sorts of buildings, so like apartment buildings, but also data centers. And they discover data centers are pretty cool. Or civil engineers work on building bridges and hospitals, and sometimes they work on data centers, and data centers are kind of cool. Um, and then a fun one from a friend who he was a civil engineer, works for a general contractor, and the impact of AI on the business. He was like, "Yeah, we used to just make estimates when people would drop off a load of like dirt or mulch or something. Now I can fly a drone with software that goes over top of the thing and estimates to like within a 1% error rate exactly the square footage or the cubic volume of that pile of dirt. You can go call a guy back and be like, "Hey, I paid for, 100 tons and you showed up and shortchanged me by 5%. Get back in here and give me some more dirt." Um, anyway, it's really, I think like the fact that I've like had AI on the brain for 5 years at least, has made me like dig in a lot. But it's really cool to see other people either have AI in their personal life or AI in their like kind of auxiliary work life, where suddenly the funding for electricians is like biggest to work on data center retrofits instead of new apartment buildings or something like that.
It's funny you bring that up, right? So like my neighbor was a sprinkler fitter for I don't know how many years. He pivoted to fire suppression systems for data centers because he can get more work,
Yeah,
because there's data centers going up all over the place every day, and he's like, I can get double the hours doing this than I ever could doing the other thing.
yeah,
So it's interesting how it's like kind of changing the jobs that people do, in addition to what the impact is on your personal life, your professional life, but then also to your point, how all of these people with these ungodly sums of money to fund the data center equipment and data centers to train these models are actually innovating and trying to at least make it marginally more sustainable than it currently is today.
yeah. I'm gonna go try and find a chart and put it on screen here that I got in the past. That just kind of shows the total impact of not just data. We're saying data centers like it's an industry. There's a whole other thing in here. Let me go and find this.
Well, it is an
This
industry. Just ask Equinix.
right. Yeah, yeah. But like when you look at I don't know, analysts. Um, Let me share this chart. Uh, Shout out our friend Greg at work who shared this one originally. Look at the yellow line in this chart. U.S. manufacturing construction measured in USD billions. And they categorize it by chemical, transportation equipment, other, and computer slash electronic slash electrical. In June of 2021, this yellow line goes like just skyrockets, right? The
Just almost
computer,
vertical.
yeah, the computer electrical build out. However, Burns and McDonnell decides to categorize this thing, they're clearly seeing something that we're seeing the first, second, third order effects of, which is that chemical, transportation equipment, and other manufacturing constructing spending are three
Hmm.
categories that keep meandering along, and computer electronic electrical shot up during COVID. Like there's a huge build out going on right now. And I don't know, to me that's just still exciting because it feels like if you're thinking about climate change, um, stuff that is electrical, electrical heating in houses, electric vehicles, your phone, that is more sustainable since it can be powered by solar or wind or nuclear or hydro, than, you know, a car with an ICE engine or
Mhm.
central, furnace in a home heating it or something like that.
Yeah, with natural gas. You know, um, the interesting thing about the timing of that too, I also think, not all of it was, the AI boom, right? Because like I look back to 2020, all of a sudden you're now in an environment where you as a business, now you need an app. Now you need a chatbot. Now you need all this stuff to interface with your customers who are sitting at home and can't go to a physical location. And there were a lot of businesses that basically overnight had to have an established web and app store presence. Otherwise, they were not going to continue to be in business. Right. So I think part of that, the reason why we saw that spike is everyone all of a sudden got dragged kicking and screaming into the web scale era, right?
Yeah,
Whether
the
they
work from
wanted to
home
or not.
era.
Yeah, exactly. Yeah,
Yeah.
whether they wanted to or not.
Yeah,
Um,
there may have also been a geopolitics thing where like maybe that build out happened just in other countries and now there was a rotation back to the US building it. Like remember that chart was US manufacturing, not global
yeah,
manufacturing.
yep.
But the fact that it was so focused on computer, electronic, and you basically don't see any spike in or change at all. It's not like the build out of transportation dropped. It's not like the amount of build out in chemical equipment like dropped. It's not like they're like we're gonna not do any more oil drilling or mining or refining or whatever. They just said we're gonna add on this huge capacity. Yeah, it seems like enough car companies couldn't ship their vehicles because of chips waiting in the supply
Chips.
chain in
Yeah.
some other country, and they're like, let's start building out a chip manufacturing facility, but we're also going to have this new app so you can talk to our salespeople from home, and our salespeople can work from home, and blah blah blah. Like,
You could yeah, you had these like giant parking lots by airports that were full of brand new cars that couldn't be sold because they were missing, since everything inside modern cars is computer controlled now, like right down to the transmission, they how are you going to function without chips?
yeah, it's not just the cars. I mean, I remember talking about COVID, and a lot of people would always focus on the like leading edge process nodes that make the stuff we do at work, the CPUs and the GPUs, right?
Yeah.
But I just walk around my house and I'm like, the thermostat, the oven, the dishwasher, the microwave, the Wi-Fi router, the TV, everything is friggin' smart, and none of it is a 4 nanometer process. Like,
Yeah, I
like,
mean that's like it's even when you talk about servers, for example, right? When everybody was having supply chain constraints, do you know what was holding everybody up? The programmable logic devices that go inside of power supplies. Those are manufactured on a very old fabrication process that just got way overloaded during that period of time, right? So to your point, I don't need to be on 4 nanometer to make a chip that allows me to ask my fridge whether I've got milk or not, right? I don't need that, right? Like I can use a lower cost, you know,
yeah,
older manufacturing process to make that.
yeah, yeah. I think we've beat that horse
We
enough
have.
on here.
So why don't we move to wrap? Um, I had talked or we had talked previously in another episode about this new economy of data that's rising out of the AI space and
Yeah, I
how
love this one.
you know
Yeah,
um, New York Times is suing Perplexity, saying, "Hey, if you want to use my articles, pay up." Right? The great old American capitalist "fuck you, pay me" mentality. I found this interesting that Reddit, after 19 years of losses, was finally profitable. Why were they finally profitable? Well, because they sold your ass out to Google. That's why. So I figured we could end talking about this a little bit just because it's like, hey, remember that whole data economy thing? Yeah, if the service is free, you're the product. And here's the perfect example of it. We're making companies profitable by them selling you to train an AI model.
Only the most thoughtful people too, right? You remember
Of,
those things? I think we shared it on here where somebody trained a language model on Slack messages,
mm-hmm.
and the result was like, "Hey, can you help me find where this document is in OneDrive?" And the model would just respond with, "Yeah, one sec." So, so Reddit's the opposite of that, where people write these like long, it's not little Twitter blog posts and stuff. It's like long diatribes talking about their day, talking about things, and they're like really thoughtful. They
Yeah.
people on Reddit seem to really care about their, the quality of their writing, and even just upvoting stuff is a hugely strong signal that this is high quality writing.
Mm-hmm.
So it seems like a hugely valuable data set for AI. Um, I am as somebody who uses Reddit and gets value from Reddit, I'm glad that they're profitable. Um, and I have a mixed feeling about whether I'd rather be looking at ads or rather them selling the data to somebody to train a language model that possibly gets released for free back to me.
Yeah.
I think if it's a virtuous cycle, I'd prefer no ads and you know, being a small paid consumer of a Gemini model that's been trained on Reddit or something like that. I think that's a durable business model I can get behind,
Well, and I think you're
but
though going to
I'm
have,
not sure. I'm not sure.
well, you and I are going to have a different opinion on that than someone who doesn't download open source foundation models and use them, right? I mean, people are, I've seen some posts on Reddit, people are like genuinely mad about this, that like Reddit is now using my content to, help, sell it to Google to train their AI overview model for Google search. And it's like people are genuinely mad and it's a huge privacy violation and blah, blah, blah. But it's like, did everyone just suddenly collectively forget that they don't pay for Reddit?
Yeah, exactly. Exactly, man.
Like, why the
Yeah,
fuck are
yeah.
you mad? Like, were you
Yeah, yeah.
mad when Facebook trained their fucking models on your face? Like,
Well, okay, I think that one's much more egregious, but people put their stuff on the internet publicly, um, signaling to try and get popularity, and then are concerned that the popular high quality stuff they create is useful for somebody else.
pretty
I
much.
posted that recipe of these cookies that are great at a certain altitude. I can't believe somebody baked cookies with that recipe and then sold them to their neighbors. This is
You son of a
unbelievable.
bitch. And they also used an AI summarization engine to get past the very thoughtful blog I wrote before the recipe that said it was a cold summer evening in October. And I was with, you ever see those fucking memes about like, oh, I got to scroll past 10 pages of your
Oh,
stupid life to get my recipe?
they're gonna be a free, yeah, oh my God, all the time. Don't get me started. They but they this is where people are going to be users of the model that's trained on the data, which is that they do a Google search and Gemini summarizes the top 5 links, as opposed to actually sending them through the link to look at an ad, to look at somebody's, you know, talking about their their mother-in-law who passed away and taught them this recipe for 3 long pages. Um, yeah, it's like it's just going to be right there, and so I think that people don't, maybe they don't fully understand how the use of the language models will be built into products in ways that it's not super clear, but will improve
Mm-hmm.
their life. Like,
Yep.
who do I need to send my emails to train a better coding model so I can be more productive during the day?
Yeah.
Have at it. I'll send my diary, all my personal thoughts. Have at it, man. Give me a better model back. I'm okay with it.
Yeah. Yeah. Yeah.
Anyway, hey, this was good. This was fun.
Yeah. This was fun. Until next time, brother.
All right. See you next week.
Yep, sounds good.